Hello and welcome to another installment of Test Automation for the Practical Programmer, where our topic will be covering creating a class for our sockets-based instruments communications. While showing and sharing the code is probably the most important thing to you, I do want to take a couple of minutes to touch on a few talking points that I'm hoping will influence your thinking on why we're doing what we're doing. Everything should have a purpose, and classes are no exception. If you watched the previous two videos, and I'm sure you have, then you'll recall that we used variables for the IP address and the port, as well as functions for things like writing commands and then reading data back. These were all specific to how we're using the instrument through Python. A class helps to group all these related and specific things together. As you build your class, you can shape the verbiage related to what that operation or what operations it helps to achieve and best guide the user on how to use it. Like other object-oriented programming languages, Python is constructed from classes. Being able to create your own helps build your knowledge and helps bring you closer to the Python user community. As you put your bits of code together, there will be instances where you'll want to pass the full states of interrelated data in and out of functions and possibly in between the layers of your software tools. And class objects can be used to do just this. Being able to neatly package your code promotes organization. This is related to the readability that we mentioned earlier, but it takes things a step further as you're creating a virtual blueprint on how the class should be consumed. As a class instance can be reused multiple times over and within the same script or program. This could be as simple as using multiple objects to control as many different physical instruments, or it could be such that your class code is inherited and used as the base for another class that you create. Encapsulation, simply put, is a means for ensuring that certain attributes and/or methods are either shared with or made visible to a consumer. While the importance of using classes cannot be stressed enough, try not to overdo it. Just because you define a function does not automatically imply that it should be rolled into a class. Make your life and thinking simple. If you're struggling to create or group functions together in a logical fashion, then it's probably not meant to be. Classes should not be treated the same as exercise equipment that's purchased with good intentions and then left to gather dust. If there is a certain set of functionality that you're finding yourself reusing regularly within the same project or project to project, then consider creating a class for it. Now, Python offers two tools that you may find useful: context managers and decorators. We will not be going into depth on these, just restating the obvious that they were created to make your programming experience easier in some way. We'll leave the research on these as a self-improvement exercise for you to accomplish on your own. Instead of typing out code through the remainder of this video, let's take a different approach. Here you'll see I've already created a class for my sockets instruments communication tools. You can see the name of the file here, which I'll need to use in my import statements, and here is the name of the class and the start of the definition. With respect to imports, note how I'm using the import of the sockets resource within my class file, keeping it local and eliminating the need to call it in my main code area, as you will see shortly. This init method is a necessity and helps the consumer to define the default state of the object when instantiated. It is the class constructor. Note the use of this self, which represents the instance of the class that helps us access the attributes and methods of the class. This is the syntax that Python has selected to best deal with methods. You will see that the first parameter of all methods within the class is self, and self is always pointing to the current object. I only define two variables in this class constructor. The first will be used to hold the sockets object that will be created when we initialize our instrument. The second is the default timeout value. Note that for both variables I use the underscore at the start of the name. This is the Pythonic way of indicating that this variable is private or protected and should not be modified outside of the object. The rest of the class definition is pulled from the communications functions we defined in the last video, inclusive of initialize, write, read, query, and close, though I've made a few slight modifications. For initialize,
Timeout val is a keyword value, so the user has the option of omitting it when they call this method. If they do, it will be set to the value established in our constructor. Otherwise, we will expect a float variable to define the timeout in seconds. I've already created a script file that will leverage our instrument comms class, as you can see here on line 2 with the import. Line 4 is where I reference my class and instantiate it for use with my source measure unit object. There are no values to pass in, which might modify the initial state, so those two private member variables used for our sockets object and the default timeout value remain unchanged. The remainder of our code is very similar to the last video, with one key exception. We still use the initialize, write, read, query, and close, but have simplified the verbiage defining them. Additionally, because these communications tools are now part of our class, I will access them through our new MySMU object. As an example, let's add another line to write a common command, the star.cls command. Notice how when I add the period after the MySMU object, the objects available within, both methods and variables, are exposed. Running the code, we can see the outcome as printing the source measure unit ID string here in the terminal area.
So that wraps things up on how to create a class for your Python sockets instrument communications. Glad to have you back, and thanks for watching.